introductory session where we will be actually talking about what is statistics. So analytics is actually about statistics. What is statistics, and why did we choose SAS for analytics? The difference between BI and analytics in IT industry, it's actually invariably being used BI and analytics as the same word. So I'll let you know what the difference is between the two. Scales of measurement, what are the different scales of measurement? We'll talk about the basic statistics. We'll talk a little bit about the probability and probability distribution. And then there are the rest of the topics which will be covered in the following session. So in this session, I'm just going to get you the overview of what we are going to cover. The hypothesis testing would be there. Whenever you actually do any research, you have to follow a null hypothesis and alternate hypothesis. So those things would be here: T testing, Z testing, ANOVA. Correlations, why do we do correlations? Why do as to see which two variables are actually correlated, and then when we are building a model, we can draw one of them, those things. OLS is ordinary least square regression. It's actually the multivariate regression, which is actually used in the industry. And logistic regression is the most used statistical technique in the industry. The difference between the two is, at a higher level, logistic regression has a categorical variable as a response variable, and here we have a continuous variable. Anyway, we'll talk about these things in the following sessions, but at this point, let me give you an introduction. So statistics, what is statistics? In the industry, whenever you do any project in analytics, these are some of the steps. These are some of the steps which are actually covered. Collection. Collection is whenever you have to actually do any analysis, you'll be collecting the data, integrating the data. It may be from different sources it's coming, so you're collecting the data. In classification, classification is you may be segmenting the data, or other classification techniques are there, decision tree or clustering. So those are all classification techniques. And then once you have the classification, you'll be doing the analysis. Analysis is actually running the model, be it logistic, be it linear regression, or be it any other model. Interpretation is actually once you have the model, you'll be interpreting it, because giving the results as it is to the client does not make any sense. So you have to interpret it, explain it, what it means, and then you present the data to the client. So these are 5 steps which will be followed in any statistical or analytical study you do or analytical project you do. It's going to be the same. So let's now understand why are we doing it on SAS. SAS is ranked number 1. SAS ranked number 1 advanced in predictive analytics provided by industry research firm IDC worldwide. SAS is in the leaders quadrant of Gartner. This is as of 2015. SAS had a market share of 36.2% as of 2012. But there are other analytical tools which are catching up with SAS, R being one of them. There are others like Python and so on. So these are actually open source tools. So because of the cost, people are moving to that, but still SAS is leader at this point. So that is the main reason why we are doing SAS. The jobs opportunity in the industry are more in SAS than any other analytical tool at this point. So studying analytics or statistics with SAS makes much more sense. So difference between BI and analytics. This was another thing I talked about during the agenda. What is the difference between BI and analytics? So having actually coming from the BI background and now into analytics, So I clearly see the difference what industry takes as BI and actually IT industry takes both of them as the same. But what the difference is, for example, here we have the informational piece, which is which region dealer and product has the highest sales. In the credit card business, which segment of the customer is most profitable? Who is the most successful salesperson? So what we are seeing here is we are actually reporting from the data which is actually sitting in the database. So it's just the historical reporting we are doing, some matrix being generated from the historical data. So that's what BI is. I'll just show you architecturally how it works. The predictive piece is based on certain conditions, what would be my sales in the next quarter? How is the profitability of my bank going to get impacted if more younger profile of people are targeted? What will be the increase in sales for Linen if a fairness feature is added to the campaign? How many mailers need to be sent for new life insurance product to get 1,000 new insurance applications? So in all these cases, what will happen is, of course, you will be taking the historical data. On that historical data, you're going to build a model, and that model would be actually going into, would be used to do the prediction. So let me actually get you into so how it happens, what is BI and what is analytics from the architectural point of view, Let's say this is I'm just going to show you a high level client. This is a OLTP, online transactional database. Well, it's not J, it's P. OLAP, online analytical processing. These are like star schemas. On top of that, there could be cubes. This is a database. This is a data warehouse in which the data resides as star schemas or snowflake schemas, and on top of that you can build a cube depending upon the. This is a BA application. In this piece you have ETL. So what is the BI? BI starts from here till here. This is a BI piece. You get the data, you extract it from the transactional system, you extract it, transform it, load it to the warehouse. From the warehouse, it's actually connected to the BI apps, which shows you in a pretty looking format, a report in a pretty looking format. So this part becomes BI. Now what is analytics? From the warehouse or some other data source as well, you pull out some data. For analysis, some kind of analysis, some say logistic regression you want to do. You want to see whether this person is going to buy or some person is going to buy a product or not. So you're going to pull the data from here. Based on that data, you're going to build a model, which will be actually that model actually. This piece what I'm talking about is analytics. So once you have the model, it can be implemented in the present DIPs, that one of the columns in the report could be that this person is going to buy, most likely to buy or not likely to buy, so those kind of things. So I hope I made it clear that what a BI is and what a analytics is here. Right, so going back to our original piece, okay, that's good for me. So going back to our original study the agenda, so the piece of BI is actually a historical reporting, and analytics is using some of the statistical methods to predict the future or say forecasting. So those kind of things fall in analytics bracket. So now whenever you go to a company, just you are in an interview, they say BI analytics. So just have a clear distinction what a BI is and what a analytics is. You can ask your interviewer or anyone, whosoever is there. So what is it? Are you looking for BI or analytics? All right, moving on to what are the different types of data available. Data is different types of scales for measurement. There are 4 different kinds of scales of measurement: a nominal scale, ordinal, interval, and ratio scale. Nominal and ordinal scales, these 2 scales are used for qualitative data. And these 2 are used for quantitative data. So what these means, I mean, what are each of these scales? In the next 3 or 4 slides, I'm going to talk about it. Nominal data is the data are measured at the nominal level when each case is classified into one of a number of discrete categories. In this category, in this scale, the nominal scale, something like a color could be brown, black, blue, red. So this is a nominal scale. Now, what is the difference between 2 qualitative scales, nominal and ordinal scale? In ordinal scale, you will have an order of these. There will be an order there. For example, very happy, happy, neutral, sad, very sad. So there is an order here. Both are qualitative, but there is an order here. Whereas in nominal scale, there is no order. Anything you write or say gender, for example, political parties, there is no order. Interval scale. Interval scale of measurement, it is the difference between values, the difference between values of meaning. The data are measured at the interval scale. In this case, let's take an example of temperature. Let's say it's 10 degrees, 20 degrees, 30 degrees, 40 degrees, and so on. But in this scale, there is no absolute zero. What does that mean? When we say a particular place has temperature at 0 degrees, it also has a temperature. It's not a zero. It's not null. It has a temperature. 0 degree is a temperature. So there is no absolute zero. Moreover, a place at say 20 degrees and a place at 40 degrees, you cannot say that the 40 degree place is twice as hot as 20 degrees place. So those kind of things are not possible. Whereas in ratio scale, this is the most commonly used scale. All our analyses are done on this. You can do addition, subtraction, multiplication, division, anything possible. Here you have an absolute zero, a true zero. What that means? For example, I'm going from my house to office. Now, distance from my house to office is 10 kilometers. My house is at 0. When I start, my origin is at 0, which is absolute 0, which is null. When I complete 1 kilometer, I have traveled 1 kilometer. I reach 5 kilometers, I've covered half the distance of my office. So there is an absolute 0, and you can do this kind of saying that this is half of it and so on. Those kind of things are possible here. This is the most commonly used scale. Now the other difference between these scales is properties. Nominal scale is identity. We see colors. Here also identity, but there is an order. Mathematical operations, we can count, we can do a mode. Here rank order, mode, median, and statistics. Interval, we have equal intervals as well, as I said, 10, 20, 30, and so on. Here we have a true 0. You can do all kinds of mathematical operations here. And descriptive statistics are possible for mode, median, range, and variance and standard deviation. So this is about the different kinds of scales. I hope I made it clear. Now the basic statistics. In the basic statistics, for the qualitative piece, it's generally the frequency distributions what we see. For example, how many times red color is occurring, how many people are happy. So you're actually counting or doing a mode of the particular variable and seeing how it is coming out. Relative frequency. Relative is relative to other variable, other categories. Percent frequency distribution, bar graphs, pie charts. These are the ways of showing. You can also do a frequency distribution for quantitative data. Your relative frequency, percent frequency distribution, dot plots, histograms, cumulative distributions, and Ogden graphs. Besides this, you can also use other statistics like mean, median, mode, with central tendency to check the central tendency. You can use that in the quantitative data as well. So let's understand what a frequency distribution is. A frequency distribution is a tabular summary of data showing the frequency of items in each of the several non-overlapping classes. The objective is to provide insight about the data that cannot be quickly obtained by looking only at the original data. Let me show you actually in SAS how it works. People who are familiar with SAS, it's good. Otherwise, I'll just show you what are the windows available. So we work on a standalone machine. It's not connected to any server, so there is no server window per se. This is the editor window where we actually write the code. This is the log window where it will show if there is an error or it's a success. Output window, you see the results of whatever code you run. This is the Explorer window where you have libraries. So in SAS, what happens is you cannot just work on the data sitting in the database. You have to bring the data into SAS library to work on it. So I'm just going to run a small code to show you the frequency piece. I'm just creating a library based SAS, and we'll just run a quick frequency. So this is a data which has the name, the gender, or sex, age. This is age 2 is actually the weight and age 3 is actually the height. And these have been categorized into senior, mid, and junior based on the age. So what we are going to do is we are going to see in which category how many people are there, because this is a qualitative data. We can actually run this using proc-prec. Proc-prec data is equal to whatever library dot the file name, table, category, and we run it. So we see in junior category there are 2 people. In mid category there are 2. Seniors we have 3. Percent, it shows how much percentage of the total is juniors, how much percentage of the total is mid-aged, and how many are senior. Cumulative frequency is the addition of all of them. As we go, it's being added, it's 2, then 2 plus 2, 4, 4 plus 3, 7. Cumulative percentages as we go, it's just increasing. So it's just the addition of these percentages, and it's going to be 100%. Now this is just one variable. We can also have a cross-tabulation. Cross-tabulation is, for example, we want to see in each category how many males and females are there. Okay, this kind of table comes up when we run a cross-tabulation frequency. Now we see in this particular there are Each of this is frequency percent, row percent, and column percent. Frequency is in Juliet there is one female and one male. Percentage, total percentage is 28.57, which are for 14.29 here and 14.29 here since it's half of it. Row percent is 50 and 50. Column percent is this way we are seeing 33.3%. Similarly for mid, for senior we are seeing one female and two males, which is 14.29% and 28.57%, makes 42.86% of the total percentage of people. And the row percent is 33 and 66, and the column percentage is 33 and the 50%. So this is something, this is like a cross tabulation of frequency as we run in the SAS, how it's going to come up. So what is a relative frequency? We just saw cumulative frequency. What is a relative frequency? The relative frequency of a class is the fraction or proportion of the total number of data items belonging to the class. A relative frequency distribution is a tabular summary of set of data showing the relative frequency for each class. I'll come to this in my next slide as to what relative frequency is. The percent frequency of a class is a relative frequency multiplied by 10. A percent frequency distribution is a tabular summary of a set of class showing the percent frequency of each class. Here we see a relative frequency. Relative frequency is relative to rest of the categories. It's 2 by 20, so that's relative frequency, 0.1. The percent frequency is going to be 10%. Similarly, below for this, it's going to be 3 by 20, 0.15, and so on. So this is about the qualitative data. Now we have another piece which is the quantitative data. The quantitative data representation, there are times when you get data in the way it is. And this is a small example. The manager of Bimmel Auto Repair would like to get a better picture of the distribution of costs for engine tune-up parts. A sample of 50 customer invoices has been taken, and the cost of parts rounded to the nearest 10 rupees are listed below. A sample of 50 customer invoices has been taken, and the cost of parts. So these are the cost of parts. Excuse me. Now, this data in the way it is, it does not make any sense. So to make sense out of it, or to make to show insights, to see insights and show it to the senior level, what we have to do is we will categorize this data or make bins of this data. Bins meaning something like this. And how do we do this binning? Although in the SAS, proc rank is a command with which you can actually make the bins. But here what I'm just showing is if you want to do it manually, how do you do it? Guidelines for selecting number of classes, you do 5 to 10 classes. Data sets with larger number of elements usually require larger number of classes, but it's advisable not to take more than 10 classes. Guidelines for selecting the width of a class, you do a largest data value minus the smallest data value divided by number of classes. So largest data value here is 1090, I believe, yes. And the smallest is 500, so okay, 1090 and 500, 520. So you do this divided by 6, since we are doing here 6 classes, we get 95 to 100, 95 approximately, so you do a approximation of 90 to 100. And what we are seeing here is 500 to 590, there are 2 parts which were sold. A relative frequency is 0.04 and 4% of it is actually sold in this category. So this way we can see 700 to 790 is the maximum sold. 1000 to 1090 is just 10% sold. So based on this, we can infer insights gained from the percent frequency distribution. Only 4% of the parts are in 500 to 590 class, as we just saw. 30% of the parts are under 700. So 26 plus 4, 30% of the parts are under 700. So 1/3 of the parts are under 700. So that gives us some insights whether we should be putting our money in the higher, the parts which cost more, which will be actually blocking our money, or should we be going into this? Other insight is the greatest percentage, 32%, or almost 1/3 of the parts costs are in 700 to 790. So this is another useful insight that around 1/3 are into this. So it makes more sense to stock these parts because 1/3 of these are sold, the rest of them are sold less. 10% of the parts are 1,000 or more. So again, this is another important insight that we should not be stocking these parts. So how do we stock these parts? Is wherever the sale is more, let's have the stock of that, more stock of that than compared to the others which are selling less. So this kind of distributions, actually this kind of data, or say a raw data, would not make sense. You have to make sense out of it. So that's what business looks. That if a person can, or an analyst comes and gives us insights into what the data is and what it is telling. So that's all about being analyst in this field. And of course, there's a data science role which has come up not long ago. Data science is this kind of analysis which I just showed you, plus predictive analytics using different statistical techniques. The descriptive statistics, we'll talk a little bit about descriptive statistics as well. So what are these descriptive statistics? First of all, this is done on the, more on the quantitative data than on the qualitative data. So far, actually we did not do the graph part, just wanted to get you into things. So resulting frequency, distribution illustrating trends, for more exact measurements, we define and study following terms and definitions in describing data. Central tendency, dispersion, skewness, kurtosis. Now these actually, once you start running, doing the SAS, coding in SAS, you will see there are different commands with which you get all of them, and you can see how things are in this. But before getting into that, let's understand what these things are. Central tendency is the middle point of the distribution. Measure of the tendency are also called measure of location. Now central tendency can be measured by mean, median. When it's qualitative, you have the both. So mean and median are the measure central tendency, to measure the central tendencies. Dispersion actually tells us how spread the data is. So when the data is widespread, then mean is not a good representative of the entire population or entire data set, because the one in the extreme corner is not near to the mean. So that's not a good representative of the population. So dispersion is the spread of data in a distribution. That is the extent to which the observations are scattered. As I said, it's spread. Dispersion actually gives additional information that enables to judge the reliability of the measure of central tendency. If the data is widespread, as I mentioned, then mean is not a good way of doing a good representative of the data. Since problems are peculiar to widely dispersed data, dispersion enables to identify and tackle problems accordingly. So there are different ways of actually tackling this kind of problem. The next we talk about, which we can actually get into, like standardizing it, having the mean 0 and standard deviation 1. Okay, I hope I'm audible. Please put your answers in the chat box. Okay. All right. So I was getting something that there's some network difficulty, so I wasn't sure. All right, descriptive statistics. Skewness. What is skewness? So it's not always that you get data in this form, which is like centered around the mean. There are times when you get data skewed towards this direction, skewed towards this direction, as we see here, and as we see here. So this is called positively skewed, and this is called negatively skewed. So that's one of the ways of depicting the data. Once you have the data, you can actually you have mean, and you can see that the extremes are not exactly same distance from the mean. So it will give you a positively skewed or a negatively skewed. In SAS, as I mentioned, there is a code where when you write a proc univariate, you get skewness, kurtosis, central tendencies, all these statistics to understand better what your data is. Skewed to the right, I've already explained what skewed to the right and left means. Kurtosis. Now kurtosis is the peak of this bell curve. Is called kurtosis. Kurtosis of a frequency distribution is a measure of peak in this. Now in these three curves, what we see kurtosis here of this one is the maximum, then this, and third is this. So this is what the kurtosis is. But generally, kurtosis, whenever you do a modeling, etc., kurtosis are not actually considered as any great measure. But since it comes whenever you run a SAS program, it comes by default. You can actually look at it, but it doesn't give much of the impression of what it is. Both are prop FEC. I just actually ran a code to show you prop FEC with one variable and with cost evaluation as well. So this is a simple code for SAS. Similarly, for quantitative data, you can also run a proc means. Here you can mention whether you want median, skewness, kurtosis. These options can be measured. By default, you will be getting number of observations, mean, standard deviation, maximum, and minimum from the data. Let me actually show you this. On the same data, let's write a code. Okay. Here we see there are 7 observations. The mean of age is 33.85. Standard deviation of 4.09. What is the minimum age? What is the maximum age? So this is what you get in proc means. Next, I'm going to show you the proc univariate. This is one of the major code or major proc which you write when you are exploring data. You want to see what your data is. Proc contents is another one which gives you whether the how many, whether the data, what are the different types of data, whether it's character, numeric, and so on. This one actually gives you more information. I'm just going to run this on age variable in a previous. Let's see how it comes. Okay. See how much information it's going to give us. It gives us the number of observation, what the mean is, standard deviation. We are seeing skewness negatively. It's a negatively skewed data. Coefficients, etc., are not much of use. Variance, kurtosis. Again, kurtosis is not something which we are much interested into, but by default it comes. Mean, median, standard deviation. Other than that, what we can see are different quantiles, lowest quantile and highest quantile. Next, we see the extreme 5 observations from the lowest side and the higher side. What are the observation numbers? So these kind of data, this kind of data actually, univariate gives all this data, and with this we can actually kind of get a little insight into when we actually do a modeling, how much of outliers are there. For example, here we had the highest value as 39. Had this been like 80, I would say this is an outlier. I can see that because the rest of the data is 28 to 37 and then 1 to 80. So how to treat that would be taken up in next or following sessions. So besides proc univariate, proc summary actually works same as proc means, but here you have to put a command of print to see the data. Other than that, proc means and proc summary are pretty much the same. I'll touch a little bit of the probability piece, and then we can open up our Q&A. Okay. Just a second, let me see.